Hi everyone, so we are here today to solve another problem from the 14th edition of University Physics. So today, we will be solving problem 28.2, the fields within the atom. In the Bohr model of the hydrogen atom, the electron moves in a circular orbit of radius 5.3 times 10 to the negative 11 meters, with a speed of 2.2 times 10 to the 6 meters per second. If we are viewing the atom in such a way that the electron's orbit is in the plane of the paper, with the electron moving clockwise, find the magnitude and direction of the electric and magnetic fields that the electron produces at the location of the nucleus. We consider the Bohr model of the hydrogen atom, where the electron moves in a circular orbit, let's say clockwise, with a radius of 5.3 times 10 to the negative 11 meters, and the charge 1.602 times 10 to the negative 19 coulombs, with a speed of 2.2 times 10 to the 6 meters per second, a constant permeability of free space, which is 4 pi times 10 to the negative 7 Tesla meter over ampere, and Coulomb's constant 9.0 times 10 to the 9 Newton meter squared over Coulomb squared. We're asked to find the magnetic field due to the moving electrons at the nucleus and the electric field. So the magnetic field due to this moving electron is given by B equals mu naught over 4 pi times QV r hat over r squared, where r hat is the direction of the position vector from the charge of the point that we want to find the field at it. We can see that the angle between the velocity and the position vector is phi equals 90 degrees. So we can write B equals mu naught over 4 pi QV sine phi over r squared. So substitute with the givens, so we get magnetic field is equal to 13 Tesla and out of the page. According to the right-hand rule, the direction of the magnetic field B is out of the page. Now, we need to find the electric field, as E equals 1 over 4 pi epsilon naught times Q over R squared. Okay, so substitute the values. We get electric field is equal to 5.1 times 10 to the 11 volt over meter. Since the electron is negatively charged, the direction of the electric field would be toward the electron. Hi everyone! Today, we will be solving a problem from University Physics 14th edition by Young and Friedman. So we will be talking about a negative charge Q equals negative 3.60 times 10 to the negative 6 coulomb is located at the origin and has a velocity v equals 7.50 times 10 to the 4 meters per second I hat plus negative 4.90 times 10 to the 4 meters per second j hat. At this instant, what are the magnitude and direction of the magnetic field produced by this charge at the point x equals 0.2 meters, y equals negative 0.3 meters, and z is origin. So consider a negative charge Q equals negative 3.60 times 10 to the negative 6 coulomb, which is located at the origin and has a velocity of v equals 7.50 times 10 to the 4 meters per second I hat plus negative 4.90 times 10 to the 4 meters per second j hat. We have the permeability of free space and the positions x, y, and z. So we need to find the magnetic field produced by this charge at these points. So we have r vector equals 0.200 meters I hat plus negative 0.300 meters j hat. We are looking for the magnetic field. So the magnetic field due to a moving charge is given by B equals mu naught over 4 pi times qv cross r vector over 3 cube. And v cross r is equal to negative 1.27 times 10 to the 4th meter square over second k hat. What we did is we cross v with r to get this answer. And now, we need to substitute this into our first equation, this one. But before that, we need to get r. So r is equal to the square root of the sum of the squares of x, y, and z. We get r equals 0.3606 meters. So, substitute all the values in equation 1. Therefore, the magnetic field is equal to 9.75 times 10 to the negative 8 Tesla K hat. So again, today we will be having a problem to be solved from University Physics 14th edition. So this time, we will be answering problem 28.17, currents in the heart. The body contains many small currents caused by the motion of ions in organs and cells. Measurements of the magnetic field around the chest due to the currents in the heart gives value of about 10 microgauss. Although the actual currents are rather complicated, we can gain a rough understanding of their magnitude if we model them as a long, straight wire. If the surface of the chest is 5.0 centimeters from this current, how large is the current in the heart? It is given that the magnetic field around the chest due to the currents in the heart give values of about 10 microgauss. We need to find the current in the heart caused by the motion of ions in the organs and cells, where the surface of the chest is R equals 5.0 centimeters from the current. Okay, we have the permeability of free space. We are required to find the current. We will treat the current as a very long wire. The magnetic field near a long current-carrying conductor is given by B equals mu naught times I over 2 pi r. Or, getting I, we get 2 pi rb over mu naught. So for conversion factors, we have 1 Gauss is equal to 1 times 10 to the negative 4 Tesla. So substitute the givens. We have I equals 2.5 times 10 to the negative 4 amperes.